How to conduct an air monitoring study. The design of an air monitoring study will depend on the scale of pollution you plan to monitor. For example, do you want to understand exposure at local or global scales, or are you interested in indoor or outdoor air pollution? Other considerations include the pollutant or pollutants being studied and the source. You may consider chemicals such as carbon monoxide, nitrogen oxides, ozone, sulfur dioxide, or volatile organic compounds, all of which may be associated with different emission sources. Particulate matter, which includes dust, soot, and smoke, could also be part of your study. There's also the option to look for biological pollutants including pollen, spores, and microorganisms, which can be important to monitor in the environment. Make sure you record both site-specific and wider meteorological data, and consider measuring and recording variables such as air pressure, humidity, temperature, and wind speed, as these can impact the distribution of pollutants. Prior to sampling, you should consider your sampling location and the logistics of positioning sampling equipment. Consider the location in relation to the potential pollution source, in addition to considering temporal factors such as the impacts of diurnal cycles and seasonal changes on pollution profiles. Available budget and resources are also important to consider prior to beginning your monitoring study. Grab sampling captures air at a specific time and location. The sample is then taken to a lab for analysis. This type of sampling provides limited exposure data and is often used for evaluating indoor air quality and determining the presence or absence of a chemical within a short time frame. Passive samplers allow air to diffuse over a sorbent material. Pollutants absorb onto the material, where they accumulate and can then be extracted for analysis. Diffusion tubes, for example, are a low-cost passive sampling technique for monitoring, for example, nitrogen oxides. Active samplers, where air passes through a device and is analysed in real time, tend to be larger and more complex due to the need for pumping equipment as well as the detectors, but provide detailed information on pollution profiles over time. Before heading out into the field, you must prepare all the equipment required for your chosen sampling method. Make sure you refer back to your risk assessment and health and safety documents, and bring spare equipment if required. It's advisable to prepare a checklist and protocol to ensure sampling is carried out consistently. Make sure you're wearing all your required PPE and your sample tubes are correctly labelled. There are several grab sampling techniques that could be used, including Tedler bags, which allow an air sample to pass into a clean and secure bag via a control valve. These can then be carefully sealed and transported for analysis. Draeger tubes are simple tube devices filled with a media which may change colour when exposed to a certain contaminant. You can use handheld meters, which provide instantaneous measurements of different air properties, including CO2 and PM10 concentrations. Remove the device from its case, turn it on, and check it is set to the correct parameters and units desired for your measurements. Before taking your readings, ensure you position the device in your sampling location. Once ready, record the readings displayed on the screen. Some devices may record this for you, and the data can be downloaded after returning from the field. Once finished, turn off the meter and store it securely for transport to other sampling locations. For longer-term and larger-scale monitoring studies, depending on budget and resources, you may want to use an automatic sampler. These can be used to take consistent measurements over time to capture temporal trends in air pollution. This equipment is able to take real-time measurements of various air contaminants, including NOx, ozone, particulate matter, and benzene, as well as environmental parameters such as temperature. Whilst this method can provide high-quality data, sampling stations are usually fixed and expensive to set up and maintain, which may limit the number of monitoring locations in a study. With passive sampling, you should choose a suitable place to leave the sampler to prevent theft and disturbance. Carefully consider the location and placement of equipment in terms of pollutant sources. You could also place multiple samplers at the same site to improve accuracy of results. To use diffusion tubes, remove them from refrigerator storage and transport them vertically in sealable plastic bags. Once at the sampling site, these should be labelled and mounted securely to a fixed object. The absorbent closed cap should be positioned at the top, with the other cap removed, leaving an open end for air to passively move into the tube. Make sure you retain the cap in the labelled sampling bags to reuse when the sample is collected. Once you've collected your sampling tubes, caps should be replaced and tubes stored in sealed containers. Remember to record the time and date of placement and collection, and store the tubes in a cool place until analysis, which should take place as soon as possible and no later than 4 months after the sampling campaign. Diffusion tubes are a simple, low-cost method and provide you with an average concentration over a 2 to 6 weeks time period, but only available for a limited number of pollutants and are unable to detect peaks in pollution. Direct handheld in situ instruments are easy to use, portable, and can provide data quickly. The level of accuracy can be variable depending on the device utilised, and they can only provide you with concentrations at the time of sampling. Automatic samplers are large, sophisticated devices that are able to provide real-time and long-term monitoring data, capturing pulse events, but are expensive pieces of equipment needing regular maintenance.